video part 2. So all 3 of those are correct. This one's in standard scientific notation, but all of them are actually 100% correct. If you're asked for standard scientific notation, this is what you put. But on a test, I'll have one of these 3 as one of the answers, and I won't do the other 2, so you don't have more than one correct answer. I don't always do standard scientific notation for answers. Sometimes it's just insensible to force it. Okay, so that's the answer to the check your learning. I did that one because it had a power of 10 to deal with. That one I just did was 3.4. It was not check your learning. That one I just did was 3.4. So 3.4 has a check your learning that goes with it. But let me go back to this one. Example 3.3, check your learning. So I've done 3.4. 3.3, check your learning for real now. Beryllium is a light metal used to fabricate transparent X-ray windows for medical imaging instruments. You can throw that whole sentence away. How many moles of BEE? I'll say, let me phrase it my way. How many moles of BE are in a thin foil window weighing 3.24 grams? If I have 3.24 grams of beryllium, so do inspect these and see how I'm rephrasing them, because these are always written to sound more complicated than what they're asking. Everything I've done so far can be phrased this way. You're either given grams and ask for moles, or given moles and ask for grams. That's all any of these have asked for so far. You just have to use your reading comprehension to see that. Numerical value, unit, label. Numerical value, unit, label equals some number of moles of BE. I'm going to come over here and put the grams. Grams of BE. And I know I'm going to need grams of BE on the bottom so it cancels out. And I need moles of BE on top so it will survive. Now look up BE on the periodic table. Top row. 9.01. Grams per mole, which means 9.01 grams of BE to 1 mole of BE. So that's what I've got to use. I need grams on the bottom here. So the 9.01 goes down here. The magic 1 goes there. And that just tells us we're dividing. Infinitely accurate, infinitely precise, I should say. 3 significant figures, 3 significant figures. So I need 3 F's up there. I'm just going to use my calculator till it dies. Uh, 3.24 divided by 9.01. My calculator says 3 significant figures, 3 significant figures. I'm keeping those 3. the 6 rounds of the 9, when you run into this situation, go over here and think of this as 59 and go up 1 to 60. 3, 6, 0. So that's what I'm keeping. I've got 3 significant figures. I put the 0 there because it counts. So I would write this 0.360 moles of beryllium for a complete answer. You could also do standard scientific notation. Yeah, 10 to the -1. Both of these are completely correct. This one is in standard scientific notation. So this time, that was the check you're learning for 3.3. I did 3.4, check your learning for 3.4. I'll write this one verbatim. They don't say AU, but I'll put it there. AU. But notice I can rephrase this. Used exactly like the other ones. And they say mass, but we mean grams here. If I mean something besides grams, I'll say put it kilograms or something. But to keep this straightforward, mass, they implicitly are asking for grams. So again, numerical value, unit, label. Numerical value, unit, label equals some number of grams of gold. Over here, 2.561 moles of AU over just a 1. I know I need moles of AU on the bottom and grams of AU on the top. And now we're totally framed in. What do you see for gold? Gold is kind of down towards the middle part, AU. Kind of to the right of the transition metals. AU. It's below CU. CU, AG, AU. It's below copper. What? Grams per mole. That's 107.87 grams of AU.
That's for silver. AU is 196.97. Sorry.
No problem. So 196.97 grams of AU. I do want grams on top and moles on bottom, so I'm just going to write it just like that. 196. So 1 mole of AU. 561 times 196.97. Calculator says stops there. I've got 4 here and 5 here, so I'm keeping 4. So I'm keeping 504.4 grams. I don't see any problem leaving it as 504.4, but scientific notation would give you 10 to the 2. Again, scientific notation, you want to move the decimal just to the right of the first digit. Times 2, 10 to the 2, yeah, that's right. So either of those is correct. This one's in standard scientific notation. All right. That wasn't the check you're answering, that was the... Oh yeah, it was. That was the check you were. Okay, good. 3.5. Copper is commonly used to fabricate electrical wire, period. You can ignore that. Verbatim. I want to rephrase this, but let me mention the CU, that means copper atoms. So, let me rephrase it. If I have 5.00 grams of copper atoms, so realize when we put this in the quotation mark, it does mean copper atoms. It doesn't mean copper in general. It's part of the label. Copper atoms, Cu is short for copper atoms. So watch this. Numerical value, unit, label. Numerical value, label. Where's the unit? Where'd the unit go? How many copper atoms are in 5.00 grams of copper wire? It doesn't say how many grams are in 5.00 grams. It doesn't say how many moles are in 5.00 grams. It just says how many. This is what I was emphasizing at the end of class last time. When you see that, when you're missing the unit, that's going to show up in your calculation. You with me? All right, 5 grams. Yeah, this is right. Okay. So what I'm saying is this, and I'll give you this on a test. I don't mind giving you this. Let me write it nice and neat. 6.022 times 10 to the 23, no unit, things. So numerical value, no unit, label is 1 mole of things. The bottom here has a numerical value, a unit, and a label. The top has a numerical value, no unit, and label. So this is how we're going to cancel the no unit situation. All right. Copper on the periodic table. What do you see? It's above gold.
63.55.
55. 63.55 grams of copper is 1 mole of copper. Should I do this next? Okay. Usually I'll do this first. Before I was doing this first. How many no unit label? So how many no unit, literally count them, how many are there? All right, and I'm going to put over here a CU. I know that grams of CU is going to go down here because grams needs to cancel. CU. This mole is here, and then down here is mole. Meaning, I write this 5.00 grams of CU, and then I'm going to involve my grams per mole here. And this last thing is this. And I need moles on bottom so I can use it exactly the way it is. Dot, 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 because this is the one that's missing a unit. CU happens. So I fill this in at 63.55 grams to 1 mole. So grams cancel, moles cancel, and we get down to no unit. That calculation will give you the correct answer. The key is when you see the unit missing somewhere, and you might be given a number. The unit might be missing over here. But you're looking for that situation to realize that's where this shows up. That becomes included. You with me? And if I did this, I would ignore the 10 to the 23 at first. I'm going to go 5.00 times 6.022 divided by 63.55. I'll just do that first. 5.00 times 6.022 divided by 63.55. My calculator says we'll always use 4 for this number. We know it way out to more decimal points, but for this class, we'll just use 4 here. 3, 4, and 4. So this needs to be 3, so it's that. The 8 rounds to 3. And now I'm going to tack on the times 10 to the 23. And I can just stick that in here for my numerical value. 0.474 times 10 to the 23. The key to know when this shows up is when the unit is missing. Truthfully, after this test, we're not even going to go back to this anymore. The whole point of chemists to have this is to get the heck away from it so we can just stay at grams per mole. We measure grams in the lab. We can relate that to numbers of things, ratios of things. And I will write, and there is a blank here. It says 0.474 times 10 to 23 copper atoms. It's not moles of copper atoms. It's not grams of copper atoms. It's not anything else of copper atoms. It's just the number of copper atoms. But I'll write this to 4.74 times 10 to 22. Either one of these is correct. I probably won't include the dots when I put these on D2L. But that's how you do that. 10 to the 23, 10 to the 22. And
And I'll write this to, why not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's how many freaking copper atoms.
I don't know how to say that. Quadriseptillion, something like that. But that's how many copper atoms are in 5 grams of copper atoms. All right, that was 3.5. You're learning. The prospector is panning for gold in a river, collects 15 grams of gold. How many AU atoms are in this quantity? But I'll say if I have grams of AU, numerical value, unit label. Numerical value, do you see? No unit. That tells you this is going to show up. The 6.022 times 10 to the 23rd definition is going to show up. And I'm going to do this. Equals some number, it's going to be a huge number, AU atoms. And I'm not including the unit there. Over here, I'm going to put grams of AU over 1. I'm going to need grams per mole. And down here, I'm going to need mole. So that way, grams cancel, moles cancel. And up here, I'm going to put dot, 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 dot. And yeah, all these need the label. Truthfully, you don't need the label when you're only using one thing. But keeping the label there will make things easier later. On the periodic table, what do you see for gold? It's below copper, a couple rows down.
196.97.
183?
96.
196.97
97.
grams per mole, which means 196.97 grams. AU. Mole of AU. All right, this time we're going to use this flipped over, like we did before. 196, 97, 1 mole. And then here we have this many blank things as 1 mole things. 1 mole, 6.022 times 10 to the 23. How do you solve this one? Again, I'm going to leave the 10 to the 23 off first. 15.00 times 6.022 divided by 196.97. Calculator says 0.458597756. 3 significant figures, 4 significant figures, 4. So we're keeping 3. We're going to have 0.459 as a 5 rounds the 8. And now I'm going to stick the times 10 to the 23 on here. And now I'll go dot, 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 AU. That's 100% correct. It's just missing that neat convention that scientists like, which would be 4.59 times 10 to the 22. AU. Either of those is 100% correct. This one's just in standard scientific notation. You with me? What do you get back to moles to grams? Oh, let's see why there's an extra gram. All right. This is 17C. Into chapter number 17C. No, it's not. Determine the mass, 17C. Yeah, it's 19C. 19C. Okay, this time, 3.3. No, it's still not what I'm looking for. I'm trying to find one that gives you numbers and asks for mass. I want to use one that you have an example for, but I guess I could just make one up. Bet I have one here. There we go. Okay, converting number of atoms in moles. This is ND2. moles of zinc atoms. Are in 2.91 times 10 to the 23. All right, so let me phrase it this way. Zn is zinc. Do I have? Okay. I'll do 4 as well. Still one more type of question I want here, but let me do this one. Okay. Phrased this way, if I have numerical value, the units missing here, how many numerical value unit maybe? So I'm going to go equals some number of grams of zinc atoms. And over here, I have that missing thing, but notice moles is not mentioned at all. You're not given moles, you're not asked for moles. That means it's going to come down to this and this alone. I've got that and none. Yeah, that's right. And then I need grams of zinc. I need blank zinc to cancel with blank zinc. No, I do need moles. Sorry. Yeah, I'll come up with more of these, but I don't think I'm giving you a way to contrast these very well. I'm writing this. That many zinc atoms. Okay, and I need grams, so I can relate this to moles this way, and then grams per mole from the periodic table. So I'm going to need ... zinc down here, and then moles of zinc atoms, and then I'm going to need moles of zinc atoms to grams. Equals some number grams. What do you see for zinc on the periodic table? Zinc is in the middle too.
65.39.
Grams of zinc is 1 mole of zinc. So I'm going to use that there. I'm going to use it flipped over. Using this here. Okay. Blank zinc, mole zinc, and I ended grams. So what goes here is the 1 mole. I need to get more of these on D2L. I don't want to have to start making them up. So the way I would do this, times 65.39 over 6.022, and then I'm going to take the 10 to the 23 here. It's here, and 10 to the 23 on the bottom. And that's just going to go away. That equals 1. 2.91 times 65.39 divided by 6.022. Four significant figures, 3, 4, keeping those 3. The 9 rounds to 5 to a 6. So it's before we were asked for how many blank no unit atoms. This time you're given this many blank atoms. You calculate it that way. You kind of have these two swapped and flipped. So that's that was number 3. In this quiz. Let me do number 4 as well. I think I want to break after that. I'm going to do percent stuff. Nicola. You guys okay? I know you're thinking you need to go organize this in your head a little bit. And yeah, you do. But just use those that I have on D2L for that type of an example. And I'll do number 4 as well. Just because of the power of 10 makes you work a little harder. Crap. I did that in grams. I did 3 wrong. All right, let me do 3 correctly. That's why I like having these piece of paper in my hand. Okay, what 3 actually asks is I've got the how many on the left side, but let me just continue with this. If I have this many blank Zn atoms, numerical value, really asking how many moles, yeah, numerical value, unit, label. And over here, and that's what I'm being asked for, so how many moles of zinc? And then over here, I'm going to write 2.91 times 10 to the 23 blank Zn. So I put that part here over 1. Yeah, grams are not mentioned here. Do you see that? We've got moles and then number of zinc atoms. You see the grams is not mentioned? God, I double check. That's why I went wrong with the other one. So the grams per mole is not going to show up here. You don't need grams. All you need is this. Times 10 to the 23, dot, 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 dot. Zinc is 1. You with me? If I actually read number 3 correctly, it would say this. The way I was phrasing this before, I would say, if I have 2.91 times 10 to the 23 zinc atoms, how many moles of zinc atoms are in, or how many moles of zinc atoms do I have? So it's really this part that I'm writing here, and then this part that I'm writing here over a 1, and then you only need this to translate to moles of zinc. That's going to cancel out. I'll do that with my calculator. These cancel, and we end up in moles of zinc. I would write this as 0.48. 3 significant figures times 10 to the nothing. Or 4.83. This one is 100% correct. This one is 100% correct, but in standard scientific notation. Okay, move on to something else, but let's take a break. What do you say?